Hello, welcome back to BlenderSushi Live Noding. In this video, I'm gonna talk a little bit about the distance node. We're not gonna make something like this, but it's basically there's this one node in Sverchok called distance. It's basically just measure 2 points and measure the distance between the 2 points. But you can also plug in multiple points, and then we'll see a little bit later. So I'll start from scratch. Go to compositing, turn on Sverchok. We can easily measure two objects on the scene using this node. So it's a distance, it's called distance, and we're gonna need objects in node. So you can use a single objects in, or you can use multiple. Let's say we use multiple, and I'm sourcing the first cube using this one. Make sure you also plug in the matrix, because this is like the positional transform. You need to apply the matrix in order for it to measure the distance correctly. And so you get this result. However, you can see it's a 0, 0, 0, etc. because apparently we are measuring the distance of the point itself. I think we need to have the crossover turned on, and now it's kind of measuring the point, measuring each and every points with each other. Let's check it using fewer text. View, text editor. So we actually have 8 by 8. Probably we have like 64 distance between the points. This might be a little bit confusing when we are comparing like two meshes and comparing the points. We get all this result. We actually, if we just want to measure the distance between the center points, we should actually get the center polygon of this guy. So get the origins, probably. I think we need to apply the matrix first. Vector matrix, just to be sure. Same with this guy. Vertices and the matrix, and the center of polygon should be the origin. We don't need to use the matrix here. Turn off crossover. Turn off separate. No data error. Let's use a viewer draw on this guy. Apparently this one is actually finding the center polygons of each, which is not what we want. I forgot. We actually want the bounding box. So the bounding box should give you the center. The mean, probably. Okay, that's probably what we want. Plug that in and plug that in. Now we can see the distance between these two objects. Sometimes I actually use the distance to measure the change, the point difference between like a, let's say I'm using like a grid here, and I can displace this grid using displacement node, displacement modifier, and I can apply like maybe cloud displacement. I'm gonna turn on all the wire so it's clear for us. This is a 0, that's before the displacement, and this one is after the displacement. I can actually change the center of this. So before and after, I usually use a distance node to measure those differences, and that's I found it super useful. So we can use this, just source the same objects, the grid, with this one with a post modifier on, and if I use the distance node for that, it's gonna be much clearer. And we can debug the distance, and we should get the distance between the original before the displacement and after the displacement. See, it's changing in real time as well, and that distance value is really useful, and I use it all the time, especially let's say if we want to scatter some objects. Let's say we are using sphere and we want to place some objects on that, based on that grid points, like so. Let it calculate a little bit, and reduce this to 8 by 8, and then turn off the edge, turn on shading, change the radius to 0.05. Okay, so we have sphere on a grid like that, and we want to control this, the size, for example, using the distance value. We can simply do that. Just use the Effector in. Let's save this real quick. Distance explore. So distances goes into this guy, goes into the scale. Now the displacement is now controlling the scaling of the sphere. Can make it a bit larger, and then it should update. I think I did this a couple of times already, but just to be really clear, so Alt G, and then let's say for this guy, if you want to control the texture placement using the empty, this guy gonna updates. So this is one of I guess pretty good example to display the power of Sverchok and then Blender modifier, and how you can transfer one data like a points. The points differences become the distance, and the distance become the scale. You can do a lot with this, and I already did it quite many times using animation nodes or Sverchok, or actually before I know about Sverchok or animation nodes, I simply use the Blender modifier itself and Blender drivers to kind of control and kind of trigger some effects. So this is super useful. See, even This will update in real time, and even just moving the mesh will have effects on this instance object. So that's one way you can look at the distance. If you actually kind of wondering what the crossover is, crossover is when you have a bunch of points. Let's say you have like 2 points, and you want to compare the distance of these 2 points with a bunch of other points. Let's say like this kind of grid. You can do that really easily. I guess I should actually do that first. So let's turn off this this guy. We don't need it for now. If I give you this later, I'm just gonna group it. So this one, measure the distance between before and after the displacement. With this guy, I'll start from scratch. Basically, let's say we have like a single point. We can't see it in the 3D view. We can't see it yet, but we can use the viewer draw to do that. Let's give it a color like red for this one. And let's have another one. This guy, color it blue. Place it somewhere else. So with this 2 vector points positions, we can simply measure it using the distance. We don't need to use the matrix because it's already the vector. We don't need to apply the matrix. We are transforming the actual point position, and the result should be immediate. So you can see, if I see this is at 0, 0, 0, this one is at 2.6400, so the distance, of course, that value. You can place it somewhere else, and it will measure the distance and updating it in real time. So that's the distance between 2 points. What if you want to have 2 points and multiple points? Let's say like a grid. Let's use plane, and this grid plane, let's make it 25 points, and let's make this smaller actually. You can see the blue. I'm gonna make it yellow. You see the yellow points and then the red points. We can measure that just by plugging this in, but you can see it doesn't quite work unless you turn on the crossover. Now we can see there should be like a 25 distance value here that we can kind of measure this guy and then how it relates with other points. You can have multiple points. I believe crossover will try to measure each and every points with each other, so that's be careful with that. So if you have like list input, if you have like a multiple vector 1, 2, 3, and let's just randomize this point position. Let's look at the view. So now I have this random point position, and also we have the yellow points. With the crossover on, we can see that we have 3 lists, and each list is like a 25 values representing the distance between this guy and with every point, this guy with every point, and this guy with every other point. If I'm not wrong, the crossover will measure, let's say you have a smaller group of points here and you have a bigger number, the distance crossover will always pick the smaller one compare with the rest of them. So if you have 3 points, you're gonna end up with a 3 times list of distance. And you can actually use this value as well to kind of instant and generate. Let's say I'm using a box, and I'm gonna instance it in a grid. This is the grid point. Okay, we have that grid, and then place the box. Man, change the box. I can like control the box height, for example, in the scale using the distance. Say in the z-axis, for example. I can simply plug this guy in, but be careful, we might actually have multiple value here. If I use the stethoscope, you can see 3 values coming in, coming out. If I just plug that in, seems to be working, but we really need to use a list item kind of to select which one you want to use. First one, second one, third one. First one being this guy. Second one, of course, this guy. And the third one is this guy. Okay, so that's with the distant node. In some other 3D packages like maybe Cinema 4D, MoGraph, or Houdini, or Maya even, or even Grasshopper, there's something called Effector. Effector. Sometimes I call it reactor. I don't know. It's kind of so many terminology. It's sometimes we just can call it influence. It's like if you have a bunch of points here, point cloud, and then you have a single point here, and you want to kind of, sometimes you actually call it force, the force, okay? And you want to measure the force. You want to have control. This guy over here, you want to have some kind of a force that influence these other points. And yeah, that's called a vector. In Sverchok, you don't have that yet. You don't have that node. But I often kind of hack it using Blender Dynamic Paint. Okay, because Dynamic Paint have this kind of features, kind of like a static. It works with a brush and canvas. The canvas being the point cloud, so the brush will have effects on the canvas. And I already did it multiple times in my live noding video. I might do that again sometimes. But I think that's a way, the best way currently if you want to use some kind of effector. The distance kind of doing that, but it's not really effector. You can have an effect of points over other points, but it's not really it's not really effector. But yeah, Dynamic Paint kind of can do that to a certain extent. I think the developer of animation nodes is working on something like this. He called it the offset. It's really powerful. It's not easy concept to grasp, but I think it's best when you are actually using it. Maybe one day. Yep, I guess that's pretty much for this live noding video. Thanks again for tuning in. If you have any question, feedback, comments, just leave it down below. Thanks again. I'll see you on the next video.